So, hello everyone. So, today we will be discussing the next topic in this module, that is downstream processing. So, in the last lecture we discussed the solid liquid separation, particularly the separation of the cells and insoluble solids. Now, next step in downstream processing is, if it is intracellular product, then you have to go for the cell disruption. So, today we will be mostly focusing on the cell disruption. We can quickly revisit what was discussed in the last lecture. So, we discussed solid liquid separation. So, these are the three common methods, that is the filtration, centrifugation and sedimentation. In the filtration, the driving force is delta P divided by, we discuss particularly conventional filter. So, there will be resistance, there are two resistances, this filter medium resistance and cake resistance. Then further we discuss sedimentation and centrifugation. So, here we have this gravitational force and there is a centrifugal force omega square r, and both we discuss how to calculate the terminal settling velocity. Now, in today's lecture we will be quickly revisit first the methods of cell separation. Then we will be mostly focusing on the methods for cell disruption, which will include both mechanical and non-mechanical methods. So, cell separation and disruption, it involves isolating specific cells from the mixed population, and this mixed population may have the cells, unutilized sugar and other components of fermentation broth. While the cell disruption refers to breaking open cells to release the intracellular product. So, this is done if your product is intracellular. And what could be your product? It can be your proteins, DNA or other biomolecules. So, this is the summary of cell separation methods. The centrifugation, it applies the centrifugal force and the separation is done by difference in density. Filtration method, the separation is based on the size and driving force is pressure. In addition, some flocculants can be added to aggregate the cells so that they can settle easily. Further, at laboratory scale, it is possible to have magnetic separation. In that case, this specific cells using magnetic beads, and magnetic beads will be coated with antibodies for high specificity. So, on the magnetic bead you are having antibodies, and antibodies will bind with your cell, and under magnetic field this magnetic beads will settle down. In addition, the high end equipment is this flow cytometry sorting. So, it sorts cells by the fluorescence and size, but it is widely used in the research and clinical diagnostics, not at the production scale. So, this is a quick comparison for different methods. The centrifugation, the separation by density using centrifugal force, it is a simple, scalable and widely used, and it required the expensive centrifuge and also it required the energy for its operation. So, it is used for the harvesting of microbial cells. Sometimes it can also be used to separate the blood cells. Filtration, this is physical separation using membrane. It is low cost and easy. There are challenges, the membrane clogging and not for very small cells. It is mostly used for the cell harvesting and clarification of broth. Flocculations use chemicals to aggregate. It is again the low cost for large volume, and the challenge here is the chemical contamination, because you are adding the flocculant that are chemicals, and so it is mostly used in the wastewater treatment. Sometimes it is also applied in biomass recovery and recycle. Magnetic separation, magnetic bead with antibodies, it has very high specificity, but at the same time it is too expensive and requires labeling. So, this is used for isolating specific types of cells. Flow cytometry, this sorting is done based on fluorescence and size. It has high precision, but it is too expensive and low throughput. So, it is suitable only for research and clinical diagnostics. Now, going ahead, today's main topic is the cell disruption. So, we are going to see the cell disruption, and these methods can be categorized as mechanical or non-mechanical. In the case of mechanical, the first is bead milling, high pressure homogenization and sonication. So, high pressure homogenization, it forces the cells through a narrow valve. Bead milling, it grinding cells with beads, and sonication, it applies ultrasonic wave to break cells. In case of non-mechanical, it includes keeping chemical lysis using detergent or enzymes, and in addition the osmotic shock to burst cells. The chemical lysis, let us say detergent, disrupts membrane. Enzymatic, enzymes degrade cell walls. Osmotic shock, this is due to sudden osmotic pressure change. Now, the choosing disruption method, the selection of method depends on what is the cell type, at what scale you are using, and what is the sensitivity of biomolecules. So, here you can see the classification once again. You can classify mechanical and non-mechanical. In the mechanical, if you are applying the solid shear, then you have to go for the bead mill and press. If you are applying the liquid shear, then it is the high pressure homogenization and this ultrasonication. In addition, there are other methods also like autoclave polarization and microwave treatment. In case of non-mechanical, you can apply acirar alkali, you can apply enzymes, surfactant and osmotic shock. Now, what are the high pressure devices? So, basically you can have the French press, you can have Rebe fractionator, you can have Rennie homogenizer or Gaulian homogenizer. So, basically you have to apply the high pressure. So, in case of French press, it is having a hollow cylinder. So, high pressure is applied and the liquid is passed through the needle valve. So, in that way there is a rupture of the cells. This is a continuous version of French press and require the concentrated cell paste in the case of Rebe fractionator. And Rennie homogenizer, it operates up to 1000 bar and 40,000 liter per hour capacity, and Gaulian homogenizer, it operates up to 550 atmosphere. Now, what happens in these cases? Cells are forced to the restricted orifice, or you can say a very limited opening. So, what they experience high shear, they experience cavitation, they experience impact and pressure shock. So, all these factors works together and results in the rupture of the cells. However, there are challenges because they are passing through this narrow valve. The valve may block with filamentous microorganisms. So, this method may not be suitable for the fungus or other filamentous microorganisms. Further, if it is not completely disrupted in the one pass, one need to go for the multiple passes. So, you can see in the case of high pressure homogenizer, so you are having cell suspension is passed or pressurized through this valve sheet, and this is the valve. Here you are applying the pressure, then they have to pass through this narrow openings. So, cells are forced through a narrow valve at high pressure. So, it has advantage like it is scalable and efficient for bacteria, but disadvantage, as you are applying mechanical pressure, it leads to generation of heat, and also instrumentation part is costly. Application, it is used for the industrial enzyme and the protein production. So, how it works? Typically you just see ln R max upon R max minus R. What is R max? Is maximum amount of product available for the release, and R is amount of product released after n process through homogenizer, and this is proportional to the K. K is the temperature dependent constant, n is number of process, and P is the operating pressure, and P to the power there is alpha. Alpha is again exponent, and both the values of K and alpha varies with the cell type. So, basically this exponent is a measure of resistance of the cells to disruption, and value of alpha varies in the range of 0.9 to 2.9 for bacteria and yeast cells. So, you can see it is proportional to the n and P to the power alpha. So, here you can see this is number of process, x axis, y axis is protein released per gram of the yeast, and it is operating at different pressure starting from 100 to 460. So, this is 100 and this one is 460. So, you just see if you increase the pressure, the rate of release has increased and also the amount has also increased. So, what it says, the protein released from yeast cell at a given temperature is a function of operating pressure and equivalent number of process in recycle operation through Gaussian homogenizer. So, you just see if you keep on increasing the number of passes, there is a increase in the protein released or your product released, but if you increase the pressure, there is again there is a sudden increase in the released amount. So, it says both number of passes as well as the pressure, both are important. If you just see here, depends on the n and it also depends on the P to the power alpha. So, with n it is maybe linear, but with P it is a power formula. Now, what were the efficiency? You can see this, if you remember the formula. So, it says it is proportional to K n P to the power alpha. It says equals to K n P to the power alpha. So, depends on the number of passes, pressure, alpha and the temperature, because K is temperature dependent constant. So, if you go for high pressure, you will result in more disruption, but if you go for too many passes, you may end up with fine debris which will be hard to separate or clarify. Temperature effect, if you increase, the release will increase with temperature, let us say up to a certain temperature, but if you are working with biological macromolecules which are sensitive to temperature, so it is recommended to work at a low temperature to avoid denaturation. Protective buffer may be added to prevent oxidation of product. However, this scale up is not very straightforward and results may vary at a large scale. The next method is the sonication. So, this is a ultrasonic vibration. So, it says ultrasonic waves create cavitation bubble that collapses, and what is the frequency? It is about 20 kilohertz. So, it breaks the cells depending on its cell wall. So, it is easy to break rod cells than coccus cells, and also it is easy to break the gram negative than gram positive cells. However, this method is ineffective for the molds. So, it uses titanium probe, that is also known as transducer. You just see the titanium horn is there. In addition, there is a temperature probe is also there, and this is a heavy duty beaker in which this sonication probe is coming, and then it releases the intracellular enzymes or metabolites. So, as you are applying this ultrasonic wave, there may be heat generation which can cause enzyme denaturation. So, mostly this method is applied at lab scale. Its advantage include fast and effective for a small volume. Disadvantage, the heat generation and not suitable for the large scale. So, basically it is mostly applied at lab scale setup, particularly for the extraction of intracellular components of a cell like DNA and RNA. Next comes applied to the solid medium. So far we have discussed those pressure were applied to the liquid medium. So, the disruption were done through the liquids. Now, we are going to use the solid medium. So, for that the ball mills are there, which is suitable for large scale operations. There is a Hages press. So, it split block of hollow and frozen cell paste are pressed into the channels. In addition, there is another variation, that is X press, where frozen cells are forced through a small hole under several 100 bar pressure, and disruption is achieved by deforming in ice. So, when you are applying these mechanical forces, so it has certain limitation, like it may be the heat denaturation of proteins, there may be protease release, so it may cause the enzymatic degradation, and further it is required a long residence time, particularly in bead mills. Then fragile components may degrade, because the cells also have different protease enzyme. They try, once they are out, they will try to start working and degrade the other desired component. In addition, there is oxidation risk, which may lead to the protein denaturation and aggregation. So, how to mitigate such effects? One, you can use reducing agents plus chelating agents. So, it depends what is the product quality that is expected. So, depending on that we choose the methods. So, you can just see the bead mills here. So, this is a typical setup here. In this you are having the rolling beads which rolls, and what happens, the RPM is set in such a way that it does not complete the whole cycle, it reaches to the top then drops down. So, basically cells are impacted by this beads and they are broken. So, here typically it follows the first order kinetics. So, ln Rm upon Rm minus R is proportional to the k into T. So, it is a function of k and time, and k is a function of rate of agitation, cell concentration and the bead diameter and temperature. So, k depends on all 4 parameters. What is the rate of agitation, what is the concentration of the cell, what is the diameter of the bead, and what is the temperature. The typical diameter of the bead we refer in terms of mesh, it is 20 to 50 mesh, and it occupy 80% of the internal space, and these small beads agitate with the cells, causing the shear force, and when they are rotating they apply the impact force from rotating discs, and its capacity is about 2000 kg per hour suspension, or one can even go with the dry cell about 340 kg. It works for algae, bacteria and fungi. So, it has advantage, it is effective for tough cells like yeast and fungi. It results or it offers a good temperature control, and as it is fully enclosed, so it is safe for pathogenic organisms. Disadvantage, because of the mechanical force there may be heat generation or the heat contamination. Application, it applied for the protein extraction from the yeast and bacteria and other applications. Now next comes the non-mechanical, mostly it is chemical methods. So we can use different type of chemicals like detergent, alkali and solvent, or one can use osmotic shock. So this, as you are using the chemicals, it is suitable only if your product is insensitive to this harsh chemical environment, and chemical must be easily separable or compatible with the product. So how does it works? Let us say detergents or solvent, it disrupt the lipid membrane. So it has certain advantage, like it is a gentle method, it does not apply the high mechanical force. Disadvantage, as you are using chemicals, so there is chances of chemical contamination and reagents may be costly. So detergents and these methods are mostly used for the mammalian cell lysis and for the purification of proteins. So surfactant, how does it work? It solubilizes lipids in cell wall, in this way it disrupts the membrane. We can have this SDS, sodium sulfonate, Triton X100, and mostly it is applied for the lab scale use. Alkali treatment can also be done, it disrupts the cell wall by saponification of the lipids. So here the advantage, it is inexpensive as well as effective, but alkalis are harsh and it may denature proteins. One can use the organic solvents, it penetrates and swell the cell wall lipids which leads to the rupture. One example is that toluene can be used. Next comes the osmotic shock. If the cells are placed in a pure water, then what happens? There will be water influx which leads to the swelling and bursting, because the concentration of water outside will be higher. So they will try to go inside, which will lead to the swelling and bursting of the cell. So typically this sudden change in the osmotic pressure causes cell to burst. It has certain advantage, like it is a simple and inexpensive method, but disadvantage, it is limited only to certain type of cells, and it is applied for the periplasmic protein release in bacteria, works well for the red blood cells and some animal cells. Apart from these chemicals, now enzymes are also being used. So one can use enzyme to digest the cell wall. For example, lysozyme, it degrades the cell wall. It is the advantage of using enzyme in place of chemical. They are specific and they works at mild conditions. So they are very effective in releasing the intracellular material. At the same time, they are selective. Limitations, because of the high cost, it becomes impractical for the large scale operations, and mostly it is applied at laboratory scale or for specific applications. It may be the gram positive bacteria or plant cells. So here is a comparison for different methods for cell disruptions. Let us say bead milling, it in this case grinding cells with beads, but it has disadvantage like heat generation. Similarly, the high pressure homogenizer, it forces cells through the narrow valve at high pressure. Sonication, it generates the sonication waves or ultrasonic waves. Chemical lysis, one can use detergent or solvent. Enzymatic, enzyme degrades the cell wall, or osmotic shock, there will be sudden change in the osmotic pressure. So advantage, disadvantage and some selected applications are also listed here, what we have discussed so far. So now we can summarize the downstream processing. It starts with first was the cell separation or the cell removal, and next step depends on the location of the product. If it is extracellular product, they are recovered from the cell free broth, but if it is intracellular product, then it requires the cell disruptions. And the for cell disruption, we discuss mechanical as well as non-mechanical methods. The mechanical, it includes grinding, high speed agitation, high pressure pumping and ultrasound. Non-mechanical, osmotic shock, freeze-thaw, enzymatic digestion, solvents and detergents. So, it has lot of application apart from bioprocessing in medical biotechnology, agriculture biotechnology and industrial biotechnology. So, in medical biotechnology, say in the gene therapy, in the vaccines and diagnostic innovations. Agriculture biotechnology, developing genetically modified crop to enhance yield or pest resistance or nutrition value. Industrial biotechnology, you see the production of any industrial chemicals like biofuels, enzymes, bioplastics and biopolymers. Now, particularly if you see in biotechnology, it is applied for the protein and enzyme extraction, biopharmaceutical developments like monoclonal antibodies, therapeutic proteins, vaccines, genetic engineering applications and environmental monitoring and bioremediations. So, with this I will stop here. So, the cell disruption is the second step, particularly if your product is intracellular. Thank you so much.